All right. Welcome, everyone. Some short announcements. This meetup or event is being recorded. The camera is over there. So if you don't want to be on the recording, we'll cut out the beginning. That's why I'm doing the announcement now. So if you don't want to be on the recording, don't jump up on stage. If you have a question and don't want to be on the recording, just tell me, I will repeat the question. Restrooms are through here, so back of the screen, there's a little hallway, or you can go the other way, past the kitchen, then to the left. Ivan, you have a question?
No.
Of course, they are recorded, but only the men's room. All right, magic microphones, hold it higher. All right, I had a list of stuff I wanted to say. So restaurants probably most important. You found the drinks, you found the pizza. We need to be out by 9 p.m., so keep that in mind. We will have 2 talks and a break. Don't make the break too long. Like I said, we have to be out by 9. And with that, I guess we can start with a welcoming that will be recorded. Welcome, everyone, to the first Berlindroid Gradle night. Yeah, that's what we call it. My name is Ketty. I'm one of the Berlindroid organizers.
I'm Jen. I'm a developer advocate for Gradle.
Oh, and we forgot our presenter, Awesome.
Hey, Tasso, Tahsin, but Tasso in short. I work for Wayfair and has been a contributor to the Berlindroid Droid meetup for some time. So I was hoping to host a meetup at our office, but yeah, fortunately for me, it was the Gradle one in our chance because I love Gradle. Yes. Seriously though, like I contribute to lots of Gradle plugins, so it's like really amazing to have the Gradle team here. Yeah, that's it for me. Welcome again, and hope you have a great time.
You're very welcome. So, like I said, I'm Jen. I'm one of the developer advocates for Gradle, and welcome everyone. And I'm so glad you're all here to listen. Couple of upcoming events for both of us. The one that might be interesting to all of you is that on Friday we are having a webinar about the Gradle Kotlin DSL. And if you want to learn about that and all of our other online classes, it's gradle.com/training.
And we usually don't do Gradle events, but Android events, hence the name Berlindroid. We have a monthly event every last Wednesday of a month. And that's 2 or 3 weeks from now. So I'm always interested. Please, quick show of hands. Who here is an Android developer and has been to one of our meetups before? Okay, so that's maybe 3/4, something like that. Who's here because they think Gradle is cool, or they work here and just went downstairs or upstairs to be here? Okay, I guess that's the rest. Or maybe there's a bit of overlap. All right. I forgot what the next slide is. Right, we have 2 talks. Volker is giving the second talk after the break about state-of-the-art Gradle Android builds. There's lots to talk about. So we put him last because at the 9 p.m. cutoff time, we'll just stop. And if you have any further questions, we will take that outside. But the first talk is by
Nelson. So, Nelson and I used to work together, so I'm very excited. He's the person that I used to go to for all of my Gradle questions, particularly anything related to Android. So welcome, Nelson, and I'm sure you do your own show.
Oh, there we go. Okay, thank you for the great intro, Jen. All right, so out of the audience here, how many people use Gradle? I know this is really obvious because we're all at a Gradle meetup. Okay, how many people who use Gradle use the local build cache, have the local build cache property enabled? And of those people, how many use the remote build cache? That is, you set up a server with remote build cache node. 1, 2. All right. 1, 2, 3. All right. And of those people, how many use Gradle Enterprise, just out of curiosity? Okay. We got one over there. They might work at Gradle, so that might be a thing. Okay. So the title of this talk is Gradle Remote Build Caches and How to Solve Them by Knowing Your Colleagues. My name is Nelson, and I work at SoundCloud. So this is the story of, well, all these remote build cache issues we've fixed internally. And to start, I'm going to just give a little background information on how Gradle works and what a Gradle task is, just so you all can follow me throughout the presentation. So a Gradle task represents a single atomic piece of work for a build. I just stole this from the Gradle documentation. An example of a Gradle task is copying files from one directory to another. It can be compiling classes, such as the Java compile task, and it can also be running tests. That's also a Gradle task. A task has inputs and outputs. So for example, if we're looking at the Java compile task, the inputs are the source files and the outputs are the class files. And this Java compile task works on a module. So if you have all your code separated into tons of modules, you have tons of Java compile tasks. If you have one huge module with all your code, then you only have one Java compile task. And so all these things are inputs and outputs to a Gradle task. Gradle tasks don't just have the source files as the inputs and class files as the outputs, but just to give a short little example, this is if you have audio.java and music.java as inputs, and this is very much a simplified view of a Gradle task, the output would be audio.class and music.class. And what's cool about this these tasks is that if you already did this work before, we can skip the compile and just reuse the outputs. And that's what this talk is going to be all about, how you can skip the work and just take the outputs from another build. So to do that, you need a build cache. A build cache is basically a mechanism to reuse outputs from other builds. Once again, I stole all this from the Gradle documentation. It allows you to refetch outputs when it's determined that the inputs to a task have not changed. And a build cache can either be local, that is, it's just a file on your file system, or it can be remote, and that is you fetch artifacts from another server. And so the important thing to note here is that you can refetch the outputs only when you determine that the inputs haven't changed. And the inputs, and this is determined by using a build cache key. A build cache key is what uniquely identifies the task's outputs based on its inputs. And so this is basically a hash of all these different things. There's a lot of different things that go into it. This is in the Gradle documentation. I'm not going to go into each and every one because they'll kind of pop up in examples throughout the presentation. But just know that there can be a lot of things that can be inputs to a task. And the reason that so many things are inputs is that you don't want to be reusing tasks that have different inputs or different environments. Like even if a task has the same C source files, you don't want to compile it the same way on, for example, an x86 machine and an ARM machine, because that would lead to different outputs, and then the code wouldn't work as expected, and you'd be really confused because you wouldn't know how to debug it. So it's better to be safe and not reuse task inputs as opposed to actually reusing task inputs. Just to understand what a build cache is, it's really just an LRU cache. If you can picture it as code, where the build cache key is the key for the map, and the build output is the value of that map. And if you can think of a build cache as just being this LRU cache, that's what we're dealing with. Obviously, it's like a server and it's running somewhere else, or it's on your file system, but that's basically what it is. And when you have a local cache, what that means is basically if you built it before, you can skip building it again. And then if you have a remote cache, if anyone else built it before, or if CI built it before, then you don't have to build it again. So you set up this remote cache server, and what it does is whenever, so at SoundCloud, we have a job that runs on our master branch, and whenever we have a green build, it'll push everything up to the build cache. It's very simple to do that. You just run the task on the CI server. And then what that means is that all our CI jobs can also pull those tasks from the build server. From the remote cache. We also set it up, and this is Gradle's recommended setup, is that local builds can pull from the server, but they can't push to the server. There's a couple different reasons for that. One is that you might have a weird state on your machine and you want to push it up and then have other people downloading it. But as Gradle's caching mechanisms get better and better, you can also just push to the remote build cache from your local machine if you want to. But this is just how we have it set up. You can configure it however you want. So it's really important in order to be able to reuse the outputs from your CI system that the build cache key for all these tasks on CI and local are the same. Yeah, and then this is just really simply how we run this task on our CI environment, and that'll just push. Since in our config, we've told Gradle that we want to push our artifacts up into our build server on CI, it just does it automatically. And this is in your settings.gradle config, which I didn't include a slide on that. I'm sorry, but yeah. It's in the Gradle documentation. So anyways, there's two big tools we used for this investigation into our remote build cache misses. The first of which is Gradle build scans. If you just run a build with --scan, you get all this information. And then the second tool is we pay for Gradle Enterprise. I'm not a Gradle Enterprise salesman. I'll let Gradle do their job. But we found it to be very useful. And it has a lot of features. One is that it aggregates all your build scans. And then you can look at every single build that any developer or any CI system at your company has run. And the other thing is task input comparison. And that's the main tool we used for this investigation. Task input comparison, what it does is it identifies what changed between two executions of the same task that prevented the output from being reused from a build cache. So to give an example of this, I just took our code, and there's this file called real SoundCloud application. I just added a white space to it and then ran a task input comparison using Gradle Enterprise. And here you can see that there is a cache miss. And the reason for that is that this file is in both builds, real SoundCloud application.java, but has different contents in this case. So this is how this tool tells you these things. You can see that the resulting cache key is different. And the reason for that is white space. So Gradle as a build tool, for Gradle as a build tool, white space is a cache miss. And that's important to know because it means that if you add comments to a file, it'll have to recompile it. Yeah. Okay. So let's start off with the first case we were looking at. So we all have these build config files in our apps. They have our application ID, build type, properties, things like that. Oh man, that's kind of hard to see. I should have gone with a white background. Sorry, guys. So what we're seeing using this task input comparison tool is that our build config file on CI and locally was different. And we were a bit puzzled because if you look at this file, they're just constants. So how could it be different on CI and local? And the thing was, it was always different. The reason for that is taking a look at where this file was being created. If you can add properties and values to your build config files using Gradle configuration. And usually you just add a Boolean like analytics enabled, true, verbose logging, false, test retry count. Oh, there's a function here. That's interesting. So we take a look at that function. Basically, it's really simple. It's just if CI, return 1, otherwise 0. What that means is this build config.java file is always going to be different on CI versus local. And that means this entire module will have to be recompiled, and the task inputs can't be reused. Just for some background info, we have this retry mechanism on CI. It's kind of like our guard against flaky tests. We just run our UI test a second time. And so we don't want it locally because then we just, if you make a change to a test and you want to run it, then it'd run every test twice if it fails. So what do we do? Oh yeah, this is just the difference between local and CI. So yeah, what do? We just remove that line from our build config, and instead we found a way to determine whether we're running on CI at runtime. Oh, I think I have duplicated slides. So very simply, what we did was we had this property, if we're running on Firebase Test Lab, which we determined by querying the settings.system content resolver. If it's true, then we tell our retry rule that it should retry once, otherwise 0. So by determining this at runtime, that means that all our compilation artifacts can be reused, at least for this module where this retry rule was being used. Okay, so the next issue. Let's say you have a module, and in this module, you have player.java, artwork.java, and then you have this empty folder. And on CI, you just have player.java and artwork.java. Git says this is the same. You can't really check in or check out empty directories into Git. But what's Gradle's opinion? Class path? No, well, it's actually just an input. Everything, directories and files are all just treated as inputs to the task. And so that poses a problem when you're working with multiple people on a team, because let's say you refactor a bunch of code, you might just have a ton of empty directories on your machine, and that'll cause build cache misses. And if you just have one file here and one file, or one empty directory here, one empty directory here, one empty directory there, all of a sudden you're pretty much not able to reuse any task inputs for any module in your code base. So Gradle helped us out here, and they came up with this interesting solution. What it does is it takes a look at all the source tasks in your project. I'll just break down that big chunk of code line by line. For every source task in your code, it configures it. And what it does is it adds this do first block. So in Gradle, you can basically stick actions, do first and do last, that run after the main code block of a task. So in this case, we're going to stick some code that happens before the source task runs. The source task is an abstract class that most Gradle tasks that deal with source files extend. So for example, the Java compile task extends the source task. The Kotlin compile task extends the source task, and tons of other things. So we add this visitor on the source file tree. So source, this is just a property of this abstract class. And we add this file details visitor. And with this visitor, what we do is for every directory, we list the files. And if the size is 0, we throw an illegal state exception. What this does is it fails the build and prints out this nice little message. So if you have a remote build, if you have an empty directory, your build's going to fail. And that's why this talk is entitled How to Annoy Your Colleagues with Remote Build Cache Misses. Because this can actually be really annoying when we first started adding it, because everyone had empty directories all over their file system. And it's also really annoying because if you look at this code, if you have a nested directory structure that's completely empty, it only checks the end of the directory structure. So you're going to have like 5 misses before you actually fix this build cache issue. So yeah. But anyways, we added this piece of code to our build, and then that solved that build cache miss. So okay, next issue. And this one is kind of similar. Oh no, not this one. So we were looking at the task input comparison tool, and it showed us that the Kotlin compile task had this property called incremental, which was different on CI versus local. And if anyone's familiar with this property, what it does is it just disables incremental compilation. A lot of people disable this on CI, as we did, because there's no reason to have incremental compilation enabled on CI, because you're never doing an incremental build. You're always building from scratch. Your state is clean. You have nothing in the build cache. And so it's a build optimization for local builds. There's no point in adding all these extra properties or computing all this incremental build information. But it turns out it's actually a performance penalty here, because we're not actually populating the cache. So what do? We just remove this property from our build.gradle file, which we were adding on CI. And then we had way more cache misses, because basically all our modules are Kotlin, and all of our modules had cache misses before we discovered this. And we had the build cache server running for several months, and we had almost no cache misses, and we didn't know about it until we ran this tool. So yeah. Next thing. So I think not everyone's familiar with build source. Build source is a special module in your Gradle configuration, or in your project, sorry. Build source is a special module, but instead of adding code to your app, it adds code to your build script class path. And so it works like any other module. It just adds stuff to your build script class path. And it works like this. If you have a directory build source, you add a build.gradle file. And so these files, these plugins will be added to your build script class path. So we were using this at one point, and we noticed that our Kotlin compile task, this is almost the exact same cache miss we just looked at. The implementation of the Kotlin compile task changed. Although this time we don't have any properties. We don't know what changed. And we looked at Java compile tasks on the same build, and they give us a little bit more of a clue in that the build script closure changed. So we're starting to think, and also this append class path dynamically. Something must have changed with the class path. So the thing is, all classes that are visible to the task class, in this case the Kotlin compile task, are considered part of the implementation of that task. So if any classes that are visible to it, anything on your build script changes, you'll get a cache miss. This happens a lot when you add a plugin or remove a plugin to your class path, you basically get a cache miss for all your compile classes. This will also happen when modifying your build source, because your build source is also added to your class path. So if you add some code to your class path, you remove a class, you add a function, all your compile tasks will be treated as their implementation has changed. But the thing was, we actually just removed our build source because we were using it for build monitoring. And once we started using build scans, we didn't need it anymore. But was it actually removed? So this is what your build source looks like when you have source files in it. And after we deleted it, actually everything in the build directory was still there. So the thing is that build is an ignored directory by Git. So when we removed it, it didn't actually remove it from all the developers' machines, and Gradle was still picking it up. So I sent out an email to all the developers and I said, hey, if you want to get build cache misses, you should remove the build source directory. So everyone went in and removed their build source directory, and then we got cache misses. But then pretty much half the team also kept getting cache misses like a couple days later. I was like, what? Well, it turns out if you just switch branches back to a commit that had the build source, then you're going to get it again. So how do we ensure this doesn't happen? You know your colleagues and do the exact same thing we just did. If this file build source exists, throw a legal state exception, please running the following command to solve your build cache issues. And then, yeah, we got a couple more of these, but since then it's been okay. All right. Moving on to the next issue. We use these in-app billing AIDL files. AIDL files are these Android interface, it stands for Android Interface Definition Language. It's basically just a file, and the Android Gradle plugin takes this file and compiles it to a Java file. So you add this AIDL file into your source directory, src main Java, and the way you do that is by the Android source sets block has a bunch of different things you can configure. You can configure the Java sources, the resource sources. You can basically tell it where to find all these files. You can also tell it where to find the AIDL files. In this case, we just tell it it's the same as our Java source stars. You just kind of litter these AIDL files within your Java source directories. And then it generates this source code down here. So this is the generated Java file. Thing was, we were getting a cache miss always for this in-app billing service.java. And oh yeah, I didn't have the pop-up, but it said the contents of the file changed. The thing was, like, the file looks exactly the same. Oh wait, but what's that hidden comment right there? Oh, it actually includes my local directory. What that means is that on CI, when we're building this, it'll be something like Jenkins blah blah blah, and on my computer, it has my username. And so it'll never generate a build cache hit. It's the same as this build config file. So what do? We come up with some Gradle hacking. So I'm going to break down this Gradle task just like I did before. For this task called compile debug AIDL, we configure it. This time we're going to add some code at the end of the task. So after it's already generated this Java file, we're going to run some code. What we were doing before was running some code beforehand, but this time we're going to fix the build cache issue by doing something else. So what we do is we look at the outputs of the task. So outputs is a property of tasks. And for all the files, we traverse each directory. This is basically a very similar pattern as before. It's a file tree visitor. And for every file that's declared as an output to the task, so this task is the task that generates all these Java files, we take a look at every single file. In this case, there's only one because we only use one of these AIDL files. And we run this line of code. This is a single line of code. I kind of broke it up to make it look nicer. But what it does is it grabs the file as an array string. So this is just every line in the file as a string array. It calls find all, and find all takes a function, and you can just pass it for a Boolean. So we just basically remove this one line that contains the string original file. And then we join up all those strings again with the new line separator. And then we set the file with that text. So it basically just in one line, this is some fancy groovy that Gradle helped us come up with, that just replaces the file and removes that line. So once that was in place, that solved that build cache miss, because now the file looked exactly the same on local and looked the same on everyone developer's machine. We also filed an issue about this with Google. It's scheduled to be, it's already fixed in a future version of AGP. I'm not sure which version, but it's a fix to the build tools. And I think they're also including a hack, the same hack we had in AGP. But there's a second part to this. If anyone saw earlier, there was kind of a little red flag there in that we were including the all the Java source files as part of the AIDL task. Actually, I'll go back to that slide because I'm probably not making sense. Yeah, so here we told the AIDL source directories that it's the same as our Java source directories. So if you have a really big module, you probably have a lot of Java files. And what happens, oh, I have to skip through all these again. Okay. Sorry. What happens is that the up-to-date check for this AIDL compile task takes 1.3 seconds. That's actually almost the amount of time it takes to actually do the work. So it doesn't actually save you any time if the up-to-date task takes that long. The reason for that, oh, I had this slide, wow. Okay. Yeah, the reason for that is this, and we had this in a really big module. So what we did was we moved this AIDL file into its own module with just by itself, and then it took about 2 milliseconds to do the up-to-date check. And then we also told Google about this in that same issue from before, and they filed an issue against Gradle about it. And you can go follow it on GitHub if you like. But yeah, everyone likes to point the finger at someone else. Okay, so we also had some build cache misses with third-party plugins. In this case, it was the SQLDelite task. So SQLDelite is a Gradle plugin that takes SQL files and generates Java source from it. And the way it works is it scans your SQL files, and based on the syntax and everything you have in there, it outputs Java code, and then you can use that Java code to run your database queries. And you stick these SQ files, these SQL statement files, in your source directories. But we're getting a build cache miss for all these source files. The reason is that by default, Gradle tasks use the absolute path of a file as the build cache key. So what that means is it includes your username as part of the build cache key. So on CI, it's going to be different. This is kind of the same thing we already saw. And this is actually a pretty simple fix. Oh yeah. So just to explain it, if you have path sensitivity dot absolute, which is the default, this is by design to be safer, so as not to reuse task inputs that shouldn't be reused. It considers the full paths of files and directories in your Gradle tasks as the input. But what we want is relative. And what that does is it uses the location of the file relative to the hierarchy. So instead of the whole entire path, it'll just use this piece right here. Yeah, this is the default. So the fix is actually, it's just this. And here's the important part. We just added this property to the source file path sensitivity of this SQLDelite task. And that was a pull request, and it's fixed. So if you're using SQLDelite, you don't have to worry about it anymore. And this was merged a while ago. So yeah. we also had a almost exact same issue with the protobuf Gradle plugin. And it's also merged but not released. I'm not going to get into that because this one was a little bit more complicated, and because not everything is very nice and uses the source task to generate output. So sometimes you have to change other things, as well as the class path of the generate proto task was using the absolute path. So yeah, in some future version, it will be fixed. Anyways, so the results of all this caching and modularization was, well, it was really a team effort. I think everyone on the team contributed in some way to our whole like build speed improvement process, whether it was just modularizing our code so we can have smaller modules and reuse those more often, to helping out investigating these issues or just even reporting them. But so before we started using this tool in December, our build times were 49.5 seconds on average, and our remote build cache usage was 3.76 seconds. The local build cache was a lot more used because it wouldn't depend on this path sensitivity thing and incremental compilation thing. But I'm happy to report that this was like last week, our build times are down to 36.8 seconds on average, with a remote build cache usage of nearly 20 seconds, and also higher local build cache usage. So that's about a 12-second savings per build, and we have about 1,000 builds per week, and that's about 25% faster builds on average. So in the end, it was a lot of fun investigations, and it was worth it because our builds are quite a lot faster. And yeah, that's it. Any questions?
Yeah, thanks for the talk. For the empty directory problem, so there's no way to just ignore it for the source key.
Yeah, there's an
generating.
issue against Gradle for it with this workaround, and then there's another workaround which just ignores it. So you can try that workaround too. We didn't try that one. But I should have linked to that issue. I would go and subscribe and star that issue on GitHub. If you search for it, it's easy to find, I think.
Hey, thanks for the talk. So I kind of myself also do this kind of investigating cache misses and stuff like that. Also, like when you focus on this, you take time to investigate and solve, which is time consuming. But what I have trouble usually is to follow up with that and make sure that no new problems are introduced, because especially when you update plugins or especially AGP, new things are coming up. Do you have any experience that you can suggest?
Yeah, that's actually a tricky one because I do see it with new versions of AGP. Like some issues are resolved and some are regressions. We're pretty new to this tool, but with every new version of AGP, I like to test like to see which of these issues are fixed, because there are even more issues of build cache misses that I didn't get into. Like for example, native compilation is almost never reused. So we like to do a check with every new version of AGP. Actually, maybe I didn't talk about this check, but you basically just take your task input comparison, you run a clean build on your local machine, and you compare that to the output of your seeding cache task on CI, and just run a comparison of all the tasks. And so just do that periodically to keep up to date and file issues for things you find. Good question. Anyone else?
Thank you. One clarification on the build source. I was running into that myself. That's why I like to tell that. It's a module, and it is not in the same way, because you said module, and actually when you treat it like a module and you put it in the settings Gradle file as the other modules are listed there, then you will end up in strange issues. Actually, it's just a folder that you create, and then you have the same directory structure with source and stuff like that. But don't put it in the settings file, which happened to me. And then I was reaching out to the Gradle team to resolve this.
Oh, good to know.
Yeah, it's I don't remember the actual error, but it's tricky. That's it.
Are there any more questions? No? Okay, thank you, Nelson.
Thanks, guys.
All right, then it's time for the break. We're actually super good in time. So we will meet back again here at 8 for the second talk. Until then, enjoy the rest of the pizza and drinks. All right. Hello. Hello. Now it's working. Welcome back. I think we can continue. Start with the second talk. Our second speaker is Volker. I'm very happy that Volker is here because Volker used to be an Android developer, but he switched to working on Gradle last year. His go-to example when doing stuff on Android, or I guess in general, was Minesweeper. Oh, there's a new Android library. Let's try to work it into the Minesweeper example. Or oh, there's a new cross-platform framework. Let's try to build Minesweeper in it. I'm very curious to learn how he connects Minesweeper with Gradle. Not sure that works, but you will find out. Please welcome Volker.
Yeah. Thank you for that kind introduction, Katie. Yeah, I think there won't be Minesweeper in this talk, but maybe we can squeeze it in. You can always squeeze in a little Minesweeper, I guess, somewhere. Let's see. Welcome everybody. Thanks to Nelson for his great talk. He put up quite a high mark for the night. I just prepared some slides and have some ideas what to talk about. So I need your help for my talk. It's not like you can now lean back and just consume, right? So inputs and then outputs, that's what we're going to talk about. All right, so first, Gradle night. There might be some confusion on what Gradle actually means because it can mean two things. It can mean Gradle.org or Gradle.com. Gradle.org means the build tool you all enjoy every day. And it's actually not only a build tool, it's a build and automation tool because you can automate everything with it. It's an agnostic build system, so it doesn't assume any build domain. You can tweak it for whatever domain you might have. And it's 100% free open source, as you all know, I hope. And then there is Gradle, the company. And that's where I work now, as Katie mentioned. We try, at least, I hope we succeed sometimes, to build happiness. And we employ all the engineers that are actually working on your beloved Gradle build tool. But we also have a commercial offering, Gradle Enterprise. And thanks again to Nelson for the great introduction, right? So I don't have to say much about that anymore. You all know what you're missing when you don't buy it. That's good. Yeah, and there's build scans. We're going to see some of that later. And we also provide training. And check out Gradle.org training. There's interesting webinars and content in general. There's blog posts. So yeah, good material. Yeah, what else did I want to mention before we jump in? Yeah, about myself. So I work on Gradle Enterprise actually. So I don't work on Gradle the build tool. So I know some about Gradle the build tool, but maybe not that much more than you all know about it. So again, help me out on it and jump in if you know better than what I tell you here. Okay, so what is a modern build? I figured we should reflect a bit on what we actually expect. And as you see here, I didn't quote what's a modern Android build because I figure the build shouldn't be about the delivery system, right? It shouldn't be so much about Android. It should be about your problem, about your domain, right? So the build should help you solve your problems in your problem domain, right? And of course, there is some Android specifics to builds that want to be delivered on some Android devices, but I hope your build is much more than just an Android build. So it's very ideally customized to your problem domain. And yeah, there are some qualities I just came up with what a build should be, and maybe you have some more. If you have, then just let me know. I feel maybe the most crucial is probably that you have a reliable and reproducible build. So if it gets flaky, then yeah, you just throw the tool away, I guess. Customizability is a good thing. And it should be universal. And with universal, I mean, you should run your build from the IDE and from the command line and on CI. So everywhere you should run the same tool, basically. And if you don't, who's been around on Android for a long time? I know some here are, yeah. So I brought this thingy here, found it in my shelf. Second edition supports Android SDK 1.0 now. Okay, so that's the hot stuff. And what, you know, I picked it up because I wanted to see what was the recommendations about the build at that time. Do you remember how we built Android apps back in the day? Yeah, there was Eclipse and there was Ant, but Eclipse wasn't running Ant, right? So you were building in Eclipse, you were pressing the play button or whatever it was called, you had it on the device, all was good, and then you tried to build it for real, and then doesn't work. So you had a totally different problem. All these fancy Ant stuff, XML programming. Well, yeah, and I think that's really valuable when your IDE really uses the build system. So you want to run it everywhere, right? Yeah, it should be self-contained. Gradle has the wrapper. We will see that. It should be fast, and I think that's one of the pain points we currently have. All have. Who thinks their build is fast enough? Who thinks it should be faster? Okay. Yeah. So let's look into that, right? And with fast, and you've seen that with Nelson's talk, fast often doesn't mean you know, be faster. It also means just do less, right? Don't repeat stuff you can get from somewhere else. If you have some expensive computation, just pull it off the cache. And as we've seen earlier, you know, these qualities are not fixed. So you can have a fast build, you can have a well-maintained build, and then after a while, new plugins pulled in, you know, build scripts added, new functionality, and then your build gets slow again, right? So it's not a one-time thing. It's not, I put in some effort and then my build is fast. It's a continuous effort to keep it fast, and that leads me to some citation, you know, to build engineering in general. So we need to realize that the engineering of the build is, you know, as complex and as challenging as regular app development, and we should apply the same best practices to it. Testability, you know, keep it maintained, keep it readable. Yeah, all the good stuff. Yeah, it's a good blog post if you want to check that out. Yeah, good stuff in it. Okay, I figured let's quickly go over the basics of Gradle. Probably you all know, but it's going to be quick. So there's a core engine of Gradle, and as I said, Gradle is, you know, Gradle doesn't care about your problem domain, but in the core engine you just have the concept of tasks, and these tasks are you tell about these tasks in some Gradle scripts, and then these tasks are interconnected with each other. Gradle computes the task graph for you, and then you tell Gradle, please execute that task, and Gradle executes all tasks that depend on that task, and then finally the task you wanted to execute, right? So if you tell it, build me that APK, then there's a lot of things that have to be executed before, of course. So that's the core engine. And the build scripts can be Groovy or Kotlin. Nowadays, who's using the Kotlin DSL? Enjoying it? Yeah, okay. I've still been struggling at times, you know, the tooling sometimes works, sometimes it doesn't. With the, you will see later, maybe not, but yeah. Yeah, task configuration, execution, I told that. And then there's also the dependency resolution, which is a big aspect. So what does it look like in general? So you have a, here we have a very simple project, you know, just the Gradle related files in there. So whenever you see a settings.gradle, you probably have a multi-project build. And we usually always see that in Android because that's what's generated by default. You have your build.gradle file where you have your logic, then you have your wrapper and some, you know, properties and the jar file that the wrapper needs. And yeah, now plugins. We've heard already. Everybody here uses quite a few plugins, at least, of course, the Android plugin. And these plugins adapt the core engine now to a specific domain. And what that allows for is to make your build declarative because you don't have to write the tasks yourself anymore, right? Before that, you would need to write, okay, do this, do that. And now the plugins do that for you. And you just can describe what you actually have. I have an Android build. Here are my sources. This is what I want to do. And then you declare that. And then the tasks are just there for you. Yeah, there are some core plugins that Gradle provides. And then there are community plugins like, you know, Kotlin, Android, and much more. And, you know, it's not only limited to source code or code in general, but we also have some, for instance, you know, the ASCII Doctor plugin where we, you know, these beautiful slides here I've created with that. And, you know, there's also Docker plugins, what you name it, some ADT automation things, yeah, whatever you want. So there's a lot of plugins out there. Yeah, and what do these plugins contribute? I mentioned it already, tasks, and then the extensions, which are very important because they allow you to make, you know, to declare what you have. And then what they actually provide is a model that you can configure and how you configure it in your build script, and that gives you a domain-specific language for your domain, right? For instance, for Android. Here's the a simple configuration for a Java project, Java library project. This is what it would look like for a C++ project, for instance. And of course, you all know what it looks like for Android. Okay, and now I figured we, you know, we do some command line thingies just to get into it a bit more, and I need your help with that, right? So I thought might be a nice idea to look a bit into how Gradle works, and I picked the K9 open source mail client because there's people who work on that close by. So let's. I don't know. Is it too dark? Really? I can make it even bigger if that helps. Yeah. Okay, so let's not do that yet. I don't find it. Sorry. First of all, yeah. So how would you start Gradle? You started via the wrapper, right? So you write Gradle W, and then you want to ask maybe what is available for the build. So what would you do? You just ask for the task, right? Okay, then you see the build starts up, and then takes a while to configure, probably because there's not a daemon running in the first run. And then you see some tasks that you can run. But how would you find out about the project structure, for instance? So we know, okay, it's K9. So what are the projects that are making K9? Anybody know? You just say, okay, give me the projects. And then you see the nice structure of all the projects you have, right, in K9. Yeah, then, okay, you might be interested in which Gradle version is running. How would you find out? Yeah, right. Okay, that's a good one actually. So you would say cat Gradle slash Gradle properties, right? There. No, in where is it? So there we go. Gradle wrapper, Gradle properties. But yeah, is there a quicker way to do it? You can just you just do Gradle -v, right? Gives you the version. And you can also just run Gradle W without any further task. Then it gives you the one as well. What I wanted to mention that I use the GDub tool. Maybe that's good as an information for you, because I then can just write GW instead of /Gradle W. So if you want to know what plugins are applied, what would you do? Does anybody know? You can ask for the build environment. And then, oh, did I? And then, nice trick, because I never like to write that in a hole. I would just say BE, because I can camel case abbreviate the task names. Okay, and then I see, okay, it applies Kotlin, good. And applies Android up here somewhere after all the dependencies. Yeah, okay. So some basic task magic here, yeah. So anything else you would suggest does anybody have some fancy little trick to share at that point? Yeah. Yeah, right. So for instance, if you, yeah, that's good, Stefan. For instance, let's look into the projects again, and then we can stop that here. I see it's not too engaging. You see, if you have some sub-projects here, you have mail common, mail protocol, whatnot, and you want to run some tasks inside mail protocol, for instance, then you can do mail protocol. You see it gets a lot of typing, and then ask for the tasks just in this submodule, for instance. Yeah, but you can also just abbreviate that as long as it's unique, right? And then maybe IMAP, and then ask it for the tasks there. I hope it works now. I haven't tried that before. But yeah, okay, that works. Good. So if you need more or less output on the console, you could have this -- console and say, okay, I don't know what's going on, because Gradle has these fancy console nowadays where it just overwrites what it has done before, right? So you can say, I want even more output. Well, it's not nice for just tasks. Maybe what can I run on that sub module? Assemble debug, maybe. Sorry. Assemble debug. Okay, and then you see you get a lot more output. All this would be skipped if you would have the normal rich terminal, right? So if I run it without that one, then you don't see that. If you need more output, you just have to add some flag again. What is it? --info, --debug, --stack trace, and all the good stuff around that. Good. Okay. Yeah, about the wrapper, maybe one word. Gradle has the concept of the wrapper, which means if Gradle itself isn't installed on your machine, you check out the project, you just start the wrapper, and then Gradle downloads the executable for you. And Catty told me that he has just upgraded to Gradle version 5.3.1. How did you do it? Gradle wrapper. Yeah. Yeah, you can do, I think, Gradle version, right? Something like that, right? You probably did it like that, but you used the, yeah, distribution type all. So that's the version we have installed. So when I run that, I would expect nothing to happen, actually, right? But there is stuff happening. So can anybody explain? T-shirt question here. Can anybody explain what's happening here? Why we are seeing this? Yeah. Yeah, yeah, that's correct. Right, because Catty said he did it via the wrapper, and we of course believe him. But yeah, what's going on here is, yeah, maybe another guess. No, I don't think so. Yeah. So yeah.
I think the problem is was using the old Gradle wrapper version, download the stuff, updated the wrapper scripts to old version. So you have to run it twice, I guess.
That's the right answer. Awesome. Yeah. So that's a little thing you might stumble upon. Always run the wrapper twice, because and if you if you look into what's happening here, then there's really there's important stuff changing at times, at least, right? So memory settings have changed here, so you don't want to miss that, maybe, right? So run the wrapper twice, then you are sure you're up to date. Yeah, okay. If that's up to date, then you're good.
Feature request. I was explicitly specifying the version I want to upgrade to. Would it make sense to then do that automatically? Like I told you, I want the graded wrapper in that version, and don't use the one I have right now, because obviously I want to.
Yeah, I cannot tell you the reasoning behind that. I just discovered it myself. But yeah, I will relate that to folks who know the history about that. Okay, I think that's all I wanted to. I just wanted to have it a bit more interactive here. So I think we can go on here. So actually, this talk is a bit about performance, because you all said you would like to have your builds faster, right? And for good reasons. So it's annoying to wait for the build to finish. But yeah, what that means is you have to know what's slow in your build. And do you actually know? Who can tell me exactly what's slow in their build? Yeah. Okay. Go ahead. There's your problem. Okay. Yeah. Good. But yeah, in general, it's not easy, right? And that's the first thing you have to do. You have to find a structured approach to find out what's actually slow, and then you want to make it somewhat, scientific. That means you measure, you find the problem in a specified scenario that you have, and then you identify what's the bottleneck. You fix it. You verify that it really speeds up your build, and then you repeat that process. Right? That's how you should tackle performance problems. And there's a few things you can do to get more insights into your build. One is you can run your Gradle run with -- profile. Who has done that already? Once at least? Checked it out? Okay. You can use -- scan to get a build scan. Who has done that? A couple more, that's good. And there's the Gradle profiler, which is a benchmarking tool that Gradle provides, and that really gives you good insights, because it takes out the the flakiness of the build. It really warms up the build a couple of times so that the daemon is in a consistent state, for instance, and then measures that one so that you get consistent numbers and you don't suffer from that flakiness between runs. Yeah, of course, we at Gradle give you the build scans and we use them internally as a given. We don't look at log files much anymore because this is way better. And yeah, it's a free service. You just need -- scan and it runs. So I would encourage you all try it out. And then I mentioned the Gradle profiler. Here you have it. It's open source project. And what that allows you is to define specific scenarios that you want to test against, right? So you say, I've tested K9 here, for instance, in a scenario where I wanted to run the check test, but I didn't want to execute the tests, which I usually run inside the check test, right? So I specified it here, run the check test, don't execute the tests, clean in between, some warm-ups, and all that is possible. It's even possible to measure the sync time of Android Studio, what that would mean for the build. Okay, so now some general advice. What should you do to gain some speed for your build? So definitely keep the wrapper to the latest Gradle version. And there another question, T-shirt question maybe again, how to find out whether you have the latest version of Gradle or what is the latest version currently, preferably from the command line. Yeah.
There's a plugin from Ben Main's dependency updates, gives you all the dependency updates, including
awesome.
Gradle also.
Perfect. Yeah, T-shirt for Ligi. I have it here. Okay, you see the T-shirts going strong here. Okay, so keep that up to date. Then JVM tuning, right? So that's important. You give Gradle enough memory, because especially in Android, there's tasks that are really hungry on memory. For instance, linting. Yeah, just what we will look into an example later. And refrain from more tweakings to all these specifics, JVM settings, because they often make your build even perform worse, because it's really a science to get that tweaked. Then always keep the daemon on, never switch it off. We even, I think nowadays, run it on CI. But yeah, maybe on CI you can switch it off if you have what we call ephemeral build clients, that are those who are recreated all the time. If you have long-living build machines, then you should keep the daemon running on CI as well. Yeah, I hope everybody of you uses that flag by default. By the way, who would you put all these flags, like these environment flags? Yeah, and there's the Gradle home directory, yeah, thank you, where you could put the default ones you want to have always on. I found that, Katie, I'm not sure why, on K9, there's a Gradle properties, this one is missing. Maybe you can add it. Okay, but yeah, you should, I mean, if your build is, most of the builds are actually coping well with parallel, but I think it's off by default because some builds might break. But if you are sure that, and you run it yourself with that, then just switch it on. And I've heard that this is not necessary anymore when you have Kotlin 1.3.30. But for now, enable the build cache for the capped task. And of course, you should enable it on your local builds as well. Who's not using the local build cache? Good to know. I hope that means everybody uses it. Very nice. So now where's the problem? Again, build scans. Your build has a couple of phases. So it initializes, then there's a configuration phase, and then it executes the task. So what happens in the configuration phase is that Gradle tries to figure out what it needs to run. So the task, builds up the tasks if needed. And then in the execution phase, it then executes the tasks that need to be executed. And what you see is you get a really detailed listing here of all the times that are spent in your build. Some red flags to watch out for. So you really want to start up fast. So if that takes much longer than a second, then you should look into that. Also, what you should always try is run some tasks just twice and see if they run again, because that means there's something wrong with the incrementality somehow, right? There are tasks who need to run again, but most of them shouldn't need to rerun, right? Because Gradle has this what's called the up-to-date checking, right? So when the output is there and the inputs haven't changed, then no need to run again. And for JUnit tests, for instance, are even cacheable for Java projects, and that's coming for Android as well. With the latest Android plugin, JUnit tests are cacheable already if you don't use resources. I saw Catty, you use Robolectric. Yeah, hopefully it's gonna come, but that's not quite there yet. Yeah, also, if a single line change, it takes you almost as long as a clean build, then, drill into that. And high GC time. I have I did some experiments with the K9 build and gave it not so much memory and run the lint task, which is quite greedy. And then I can show you what happens. You see that quite nicely here in the performance tab. Because you see the build takes 1 minute 14 and you spend 50 seconds garbage collecting. That's not too great, right? Yeah, so give your build enough heap and then look at these numbers, right? In the build scan, it's quite easy to see. Just look at the garbage collection and you'll find it. What you should avoid is run any logic in your settings.gradle file, because it's executed all the time. When the build starts up, it needs to execute that logic, right? And here you see if you start traversing the file system, that can obviously take some time and slow down your build. Then concerning the daemon, right? We mentioned the Gradle daemon. I didn't explain what it actually is. It's there to speed up the startup, right? So the daemon stays around. So there's a JVM warmed up already. And when you run the build, it doesn't have to come up again. So it's already there. And the daemon can do all sorts of in-memory caches and caching. So you want to keep the daemon running and you want to keep it healthy. And there's a special tab dedicated to that in the build scans. And you can just see this one has been quite around for quite a while, right? So it's over a day old already, has run 100 builds. But yeah, what I was wondering about is the last line here. So there are 7 other daemons running on my machine for reasons, and it's not easy to see sometimes. So you have Gradle w -- status that tells you about the daemon, and you can say Gradle w -- stop, I think, or is it just stop, to stop the current daemon, but Gradle only shows you the daemon for the current Gradle version. So to find all the daemons, especially if you switch between builds and they might run on different Gradle versions still, so you just need some command line magic to find out what's actually running. Okay, so that's about startup time. And then we have the configuration phase where Gradle applies all the plugins, evaluates your build scripts, and runs the after evaluate blocks, where especially on Android, a lot of tasks are created dynamically at that time, right? In the after evaluate phase. So, and what's important about that is configuration time runs always. When any task any Gradle run, so configuration has to be done. That has to be done always before any task can be executed, right? Even when you run Gradle help or task, or when you sync Android Studio. That's why it's important to keep that as quick and as fast as possible. And there are a few things you need to watch out there. Avoid dependency resolution at configuration time, and be aware of inefficient plugins, right? So, and build scans give you a good overview about what's going on in your build at that time. Just have a look at that. I have many more slides on configuration and examples, but I'm not sure if we should drill into that more deeply now. Yeah. Okay, and then the execution phase, and then you know, Nelson covered that quite nicely already. So you have task input, task outputs, and whenever the inputs are unchanged, you can reuse the outputs. So you want to make sure that your tasks are incremental. That means they can run again on the same branch, on the same machine. If they are even cacheable, that means they can be pulled from the local cache on the same machine, but maybe across branches. So you don't have to rerun them across branches. And if you have the remote cache enabled, then they can even run across machines if you get the cacheability right. And that's the big challenge nowadays, where even Google is still struggling to get that right. There are a lot of, or quite a few issues still, but they are getting fixed, you know, one after another. And it's great that, you know, all these things are now easily to find out with the right tooling. Yeah, and of course, parallel execution. Also, what we didn't mention earlier is that you should look out for tasks that write into the same output directory. That's always a problem. If you have overlapping outputs, you don't want to do that, because then you kill your cacheability. Yeah, just mentioned, right? Incremental build, nothing has changed, so nothing should be executed. And that's an easy test you can run. If there's anything happening, then you need to watch out for, maybe I have a timestamp somewhere, or maybe there is some commit numbers that I use, or anything that's somehow flaky. To make compilation faster, yeah, I think we all know that smaller modules are better, because then if nothing changes in that module, then it doesn't need to be recompiled. And it's even, you know, even if you do some changes in the module, but it's not an ABI change, at least for Java, right? So the interface doesn't change, then the consuming modules don't even need to be recompiled. So that's really nice. But I think that's not there for Kotlin yet. So for Kotlin, you have to wait for that. Yeah, and a few more resources on that. There is a great talk by a colleague of mine, Tony. You should definitely watch it. And we have really extensive documentation about all these caching issues. And there's one part I would recommend, especially for you on Android, that's dealing specifically with Android build performance. Yeah, okay, so more details about configuration. I skipped that for now, but I would like to, before we finish, I would like to really make a case for the build cache again, because I think that's really the main thing to speed up all your builds. So you definitely need to have it on locally. You have to make sure that you don't break the cacheability when you do a lot of custom tasks, or maybe you pull in third-party plugins that are not really cacheable. So check that out. And ideally, you want to really use the remote cache. Yeah. So the cache key is based on inputs. Well, we've seen that in the task in the talk from Nelson already. So you have your inputs. There's a key, a hash computed on that, and then if we have the outputs for you, you provide us with the with the same key. We give you the outputs, and you don't have to redo all the work. Yeah, I mentioned that locally, you know, if you have the local build cache on, you can switch between branches, and you should try that out, right? And it should come from the cache. If it doesn't, there's an issue there. And yeah, you need stable inputs, repeatable outputs, and that's really something I wanted to point out again. This path relocatability. So if you have absolute paths that you rely on in your build, then of course you cannot move that. You cannot even move it between directories in your cache. So you could try that out, check out your project twice in a slightly different directory structure. If you don't get the cache hit rate you expect, then drill into that. Yeah, enabling, we've seen that. And I mentioned there's cached unit tests now coming in AGP 3.5. Ah yeah, the remote build cache. We have it again. So Nelson mentioned that setup earlier. So you, as a developer, you push in into your local cache, and you pull from your local cache. But on your CI, you want to configure it in such a way that it pushes into the remote cache. And if you don't get a cache hit on your local cache, then you can ask the remote cache again, and you will get a hit there ideally, and you pull it down, put it in a local cache, and reuse it. And from then on, it comes from the local cache. Here's the setup for the remote cache, right? So this is what it looks like somewhat. Just a few lines of configuration, and you can even put it in an init script if you want to, so that you can transfer it between different builds in your organization. Yeah, and it's really just this line to enable it, right? If you want to try it out, there's a Docker image. Just start it up here. This should be your local directory where you want the remote cache to write into, and then you are up and running. You have the remote cache working. So if you work, yeah, if you work in a sizable team, that will be an amazing speed up of your build times, I think. Yeah, and if you need more, of course, like if you have a distributed team, you need nodes that talk to each other. You know, somebody commits in Australia and you want to have it in the States from the cache, and you can always ask for more. Okay. Yeah, I have some more slides on improvements in AGP lately, but I think we maybe we can just look into one build scan I made from the K9 project. That might be interesting, I hope, because what I found here is this is the build running against AGP 3.2.1, right? You have upgraded already, but this is from earlier. And what you see over there is that there are almost 3,000 tasks created at configuration time. But nowadays we have the configurations avoidance API that helps to not create tasks that are not needed at runtime, right? So it tries to defer the configuration. And Google has been busy on using that API, and you see that's the same thing for AGP 3.3.2, I think. So quite some improvement. So always try to keep on the latest version. And maybe as a last example, here's the cache the cached unit tests. Is that the right one? That's 3.5 alpha twice, so no. So here we have the build running on, well, you can see that here. It's running on AGP 3.3.2, and it takes, where is it? Takes 1 minute 6 seconds to run the test task. I think it's only in the mail sub projects, on the mail sub projects. And if you run it again on AGP 3.5, which is alpha 10 currently, then you don't see any test tasks because they are not run at all. If you look into the timeline, you find out down here from cache. Everything's coming from cache. So, and what time did it take to run that build? 1.7 seconds. Yeah. So good times ahead for Android and testing. Yeah, and that's about it, right? So what's the conclusion? The takeaways: know your build means know what's slow, then monitor and measure, and yeah, avoid unnecessary work, especially in configuration, and then repeated work in executing. Okay, and that's all I have. Thank you.
I guess we have time for 1 or 2 quick questions, if there are any.
Hey, thank you for the talk. How does the Android Gradle plugin or Gradle itself know that it's safe to cache unit tests? Like, for example, if you're doing a network call or you're relying on some timestamp, you might have a non-reproducible unit test. So how does it know that it's safe?
Yeah, I think it just doesn't consider that as an input, right? So if you have additional inputs to your, do you hear me? If you have additional inputs, like, if that's something like network or some system properties or something you depend on, then you have to explicitly declare that as an input of your build, right? It's similar to your example from the C++ builds, right? Where you have environment dependencies. You said, okay, on ARM, of course, it's different than on x86. And it's very similar to that, right?
Me? Okay. First, thank you, Volker, for your talk. I have 2 questions, if that's okay. First off, is remote caching okay to use in Germany? Because, of course, there are a lot of concerns about where data is stored, and are these artifacts and the data, are these stored in Europe, or are they remote? Is it fine?
Yeah, okay. So the remote cache is, I just showed you can spin it up yourself. So wherever you have it, you host it, it's there, yeah. It can even be in the same office, just spin up a machine there, and then it's running. If you use, some enterprise offering, then yeah, we can, that's a hosted offering itself. So that's not an issue. That's the answer, I guess, right?
Sorry, I misunderstood. Thank you. My second question is that often, sometimes we'll have very unexpected build failures when we perhaps pull from develop and somebody else has made a change. Maybe they've introduced a new module, and of course, we'll be using caching and all these incremental builds as much as possible, and then we'll have very, like I said, unexpected build failures. Is there a way that you would recommend to try and debug these or try and find the offending cause to try and maybe we can use like kind of clear your build cache or something, but sometimes I've tried to actually completely destroy everything I have cached, including everything in my Gradle folder in my personal directory. How would you recommend trying to diagnose this?
Oh, yeah, it's a tricky question, I guess. Yeah, of course. I mean, then you really have an issue with cacheability. That means you have the same inputs that produce different outputs, right? And then, of course, you have what's called cache poisoning, right? So you have some, some crap in the cache that gets served then back in. But you can always run a build with --no build cache, for instance, and that should, help you mitigate that, right? And of course, you can create build scans every time you run the build, and then you can compare what you have. And then
I'll
see,
give it a go.
This one was running, this wasn't. Okay,
So
let's dig into that. But
sorry, I'm seeing we have lots of questions left. Unfortunately, we're out of time, but I think Volker isn't disappearing right away, so maybe you can answer some questions on the way out. Thank you so much to Wayfair for hosting us. Yeah, please bring empty bottles back to the kitchen area, and hopefully see you at either a Gradle event or at a Berlindroid event. Bye.